Hi guys, welcome back to another video. And this video is going to be a start of series in which we're going to be creating a database engine from scratch in C++. And this is going to be the first part in which we're going to be creating the REPL environment and the front end of the SQL parser basically. So I don't have a working title of this project yet. I thought of using ChatGPT for the name of the project, but something about using ChatGPT or AI in general for stuff like this, like generating names and stuff, it just feels weird to me. So I didn't use that. Even though ChatGPT suggested me some good names, I'm not going to be using them until I don't come up with a name of the project of my own. I'm going to be using or calling it DB engine. So yeah, so we're going to be doing mkdir DB engine. We're going to be going into DB engine and we're going to be opening VS Code over here. So now, first what we'll do is we will create a new folder. We'll call it src. Inside that we'll create another folder, and that would be the front end, or basically the parser. So, uh, one second. Yeah, okay. And in the front end we'll create a new file. I think we'll call it lexer.hpp. And one second. Yes. Okay, it's like this lexer.hpp. So, and now we're going to be defining how does it exactly work. I mean, sounds very basic, but I did forget this. Like, so we okay, in the .h file we just basically okay, so yeah, if not defined lexer underscore hpp, we're gonna define lexer if if not defined, we're gonna be defining lexer hpp and end if. So this should work. And now uh, I was thinking of implementing this as a class, so it's gonna be a class lexer. So class lexer, and then it's going to be having a constructor. So it would have a constructor. Do we do it like this? Okay, we got to add public and private spaces first. So we'll have a public space and we'll have a private space on top of it. And in the public space we'll obviously have the lexer, which would be the main lexer constructor. And then what else are we gonna have? Okay, now let's just keep it till here, and now let's create the lexer.cpp file, and we're gonna be doing hash include. Do we do hash include over here? One second. Yeah, we do hash include lexer.hpp, and now let's just define the constructor. So lexer, and then see out, or we do it like this. Okay, why is there an error? Okay, see out, this is from the lexer constructor file. I'm just like what do you call it, seeing whether this works or not. And we do have to include iostream, right? Should work now. Should work. Okay, now inside the src I'll have to create a, how do I create a, okay, and I'll create this, I'll call this main.cpp, I guess, and we'll do hash include iostream, and we're going to be doing hash include lexer.hpp. Okay, I think I have to do it like this. Wait. Okay, so I have to. I think this was DB engine. So is it DB? Oh yeah, DB engine slash src slash frontend slash lexer.hpp. Should this work? Yeah. Okay. Let's do int main. We're returning 0. Cout. This is from the main program. And am I recording first of all? Yes, I am recording. I don't trust OBS these days because I don't know, my OBS is kind of glitching. It would stop sometimes, so whatever. So let's do g++ main.cpp as main and we run it. And then also we're going to be clearing the screen. We don't have a file. Okay, we gotta go into src, no such file or directory. Why is that so? It works now. I mean, I haven't saved it, I guess. Okay, I have to refer back to my own project, including stuff and all this. I don't know, I find it kind of tricky. Okay, we just have to pass in get it. Okay, so this should be good enough. We don't have to do the entire thing, and not like this. This should be good enough. Yeah. Now we can create a Lexer. We call it main Lexer. Now let's run this. Undefined reference to Lexer. Okay, now why is that so? Oh, we gotta call the constructor, I guess. Okay, but should have been executed, right? Okay, what if I define it over here itself? Actually, I haven't done this, and when actually I made a post on Reddit about my compiler, and there were some people who actually noticed that my .hpp file itself contained the implementation also, which isn't what is the conventional way. So actually, I haven't worked with like linking HPP and CPP files. Like it would sound very basic, but yeah, I haven't done that. So okay, we gotta include. I think. Okay, oh no, include IO stream. This is from the main program. Okay, even this isn't running. Why is that so? Okay, I have to come back to this video again. I don't think, even if I use Pragma once, I don't think it would make much of a difference. Okay, do I call it .h? rename this to .h, and now let's include .h. How is Lexer undefined now? Okay, it isn't. And this would also be .h, and this shouldn't give us an error. Name followed by, okay. I don't know why this is giving me any kind of error, but okay, it isn't. Let's see what's happening now. Okay, still the same. This is a very basic glitch which I'm not like. One second. Should we switch to pragma once? Let's do pragma once. Even though I like the syntax of this better, but pragma once class monster, and then what else do we have? We have private and public spaces. Is it in? Wait. Let's just int test. It's gonna be taking a value. And now in the Lexer.cpp file, we are gonna be passing int test. Let's do the value of the test and test, and over here in main.cpp should be Lexer int. Why is there an unidentified? We do have it over here. Okay, we have the basic implementation over here. Why would that make any difference? I think it has something to do with the location of the file, maybe. Well, I'm pretty sure I'm typing the same thing. Okay, let's just move it to front end. Now let's move this, and now cd front end. Let's see what's happening. Great. Honestly, I have no clue why this is happening, and this is kind of irritating. Okay, let's watch this again from start, and now we have in CPP we have the implementation of the Lexer file. Okay, now let's just do one thing. Let's just first create like a version over here, make it public and Lexer, and so int data, the value of data and std and line. Okay, let's not include this at all. It does work like this. Okay, create a new h file, call it monster, like whatever you want, like lexer.h. Okay, we do have that, and inside that what we do is we use hash pragma once and get to find the outline of the class. So let's just do it like this, and let's just have nothing in private. Let's make everything public for now. Now we should have a lexer.cpp, and inside that we include the lexer.h file, and then we define the constructor as follows. Cool. I'm pretty sure this is what I was doing, but I don't know what's wrong. Now if we comment this, and now let's do hash include what was it called, lexer dot h. We don't have a hpp, lexer dot hpp. Let's see. Okay, find a reference to constructor while using the header file implementation and C++. Okay. Okay, so I'm not gonna be wasting more time. Like, this is just plain stupid. This is very irritating, and I am very pissed off. But doesn't matter. We're gonna be not using this altogether. Maybe in the future, but as of right now, we're gonna be creating the front end in the class itself. So I'm gonna be taking it back to the SRC. Is that even possible to do it in VS Code? So I'll create a new file called main.cpp. I'll just copy stuff from here and just remove this entire thing. Anyways, so now let's create the Lexer over here. So we have this, and this. Okay. So first, what we're going to be doing is we're going to be creating a REPL environment. So if you don't know what a REPL environment is, REPL stands for read, evaluate, print, loop, I guess. So it's basically like command prompt. We're going to be creating a small version of shell, which is going to be the way the user is going to be interacting with our database application. So let's make. We do need an instance of our Lexer, but okay. First of all, let's do while true, and inside that, what we'll do is let's do cout db engine, and then we'll do get line. Okay, std cout db engine, and then we're going to be including strings, hash include string, and then we would have should I do it as like like, should I implement an input class which would handle all of this? But okay, let's just do it first, like the kind of normal way. So we just call this input buffer, and we're going to be doing get line sin input buffer. See out, this is the value, which is basic printing it out. The way this video has started, I swear to God, I like spent, I think, the first 10 minutes of this video just looking up how header files work. So that's very embarrassing. But so std getline, if I'm not wrong, that work, and std sin. Yeah, cool. So let's compile this, and not this. We go back and compile this, and it's something like insert into main one rn, and let's say my roll number 231039194. We won't use semicolons. I hate semicolons. So yeah. So now, okay, now we're gonna be we need to kind of work with like we're gonna be we have to decide what would be the syntax of the language. So basically how we would parse stuff. So insert into is very normal. I mean, it's normal, but something related, something else. So I think, like, okay, first of all, what kind of operations are we looking for? So first we have obviously have the create new DB. So we create new database, and okay, first let's deal with insertion. So insert, how do we insert? So we'll do is push into table name or db name value, and then the value set. Should we do it like this? Push into db name value. I think I should have prepared this before like starting the recording of the video, but I think it doesn't matter. So push into, or should I stick to insert? But no, I'll just or I'll just stick to insert. Or okay, no, never mind. I'll just do push. So now we have to create a bunch of, what do you call it, tokens. Basically type def enum token insert token into token id. This would be for the name of the db and stuff. Okay, we'll do push into db values something like this, and then I think this is good enough, and we'll just call it token set. And now what we're going to be doing is, okay, I'm going to be putting this inside the private space of the Lexer itself, I mean. And there should be some space over here. Yeah. Okay, so what we'll do is we'll first create an instance of the Lexer. We'll call it main Lexer, and now we don't need this. We don't need anything. I think we would just do see out initializing the Lexer, something like this, and what we'll do is we'll just do main Lexer dot handle input buffer. Even though actually when I was looking into the tutorial of this, there was this guy who wrote this in C, and in C basically he every time he allocated a char set using malloc, and the size of that was constant, and every time he had to free it. Even though that's a bit more hectic, I really loved the like aesthetics of the entire program. It just looked better. Like just using a string for an input buffer just makes things much easy. So it would return a token set if I'm not wrong. So anyways, what we'll do is we'll just do a void implementation of it. So void handle, and it would do a string and input buffer. This is the input buffer. I don't know why I keep printing stuff, but whatever. Cool. I think we'll have a wrapper class which would yeah, I think we'll make a wrapper class. So class we call it evaluation wrapper, and we're gonna make everything public, and it's gonna have a evaluation wrapper is going to have what's gonna have, it's gonna have a new Lexer. So should we do it like make it private, and inside that Lexer pointer, let's do main like something like this, I guess, or like keep in caps. So main Lexer, and we're gonna also have a parser. So but this should work. And now inside this main Lexer is equal to new Lexer, and yeah, we don't need, okay, we need this. Now we don't need to declare anything over here, and we can just pass stuff to evaluation. We need an evaluation wrapper, main IO, I guess. Okay, let's make it like a point, like using new is equal to new evaluation wrapper. So what we'll do is we'll just have a handle over here, void handle, which would take an std string, and we'll call it input buffer, and see out this. One second. This is the value of the input buffer, and again. So yeah, now we have to just pass it to the main IO, main IO handle. It's gonna handle the input buffer. Let's run this again, see what's happening. And we don't need to print this. Cool. So we do have this now. No, we don't need the handle thing in Lexer. Should I just make it okay, maybe we will make this and own a class of its own, and yeah, I think we have this now. So we are going to be calling the Lexer. Okay, now we are supposed to have a tokenized function over here. So in the Lexer we'll have a tokenized function which would take an std string input data, call it input data or input buffer, call it input buffer. How did I implement, like, what was the naming convention I had used? I generally stick to the naming convention which I've used previously. So okay, it's should be here, I guess. Yeah. Oh, okay, now it's gonna be in headers, right? Lexer.hpp. Yeah. Okay, there wasn't any kind of what do you call it? Okay, so what we'll do is we have a main Lexer, and inside the main Lexer, we'll just call the tokenize function. We'll pass in the input buffer, and in the tokenize function we don't need this anymore. And in the tokenize function, what we'll do is I have forgotten like everything. So okay, so we do have some stuff, right? Like, so first, do we call the initialize? So first let's do main Lexer initialize the input buffer, and then we tokenize it. So in the void initialize, take it the string input buffer, and then we would have some private variables, right? So we have the int cursor, int length, I guess. So you call it length. What else do we have? I think this is good enough. We'll have a cursor, we'll have a length, and the initialize, we'll set the cursor to be equal to 0 and length to be equal to input buffer. Input buffer dot size. So now let's just see out the length and see what's happening. Initialize. What did I wrote? Initial. Great. Rn should be 5. Great. So we have this now. Now we gotta have an advanced function, right? So should this be in the private section? I think so. So void advanced. What we'll do is if cursor is equal to length -1, this means that we are at the end of the input buffer. List return I think it should be a char, right? Because we're gonna be, it's similar to what I had written in the compiler implementation, but yeah. Else what we'll do is we'll just return the, do we save a copy of the local buffer, like a local copy of the input buffer? Local input buffer. So what we'll do is local input buffer would be equal to input buffer, and then for tokenize we don't need to pass in anything else. Let's return, what we'll do is local input buffer, and what we'll then return, what do we return then? Cursor plus cursor, I guess. Yeah. Cool. So we'll do tokenize, and we have this, and okay, we should also have char current, and we'll set the current to be equal to local input buffer. Local input buffer, and then we pass in the cursor over here, and then while we are advancing, we also want to change the value of the current, right? So what we'll do first is current is equal to local input buffer plus cursor, and then we also return current. Great. We have this, and now okay, now while okay, over here also, like I think we have to set the current to be equal to and then we just return the current. So while current we're going to be formulating strings, right? Okay, now let's try to do something like insert into my DB. Let's just insert one Rn. It's push, right? I'm sorry. push. Actually, you know what? We'll stick to the normal convention. I don't think so. Let's do insert. Now, over here, it's insert only. Great. Insert into my DB. So we need a token for int. So token int, and then we need a token of left parenthesis, and token of right parenthesis. Okay, no. Token quotes here. Do we need token quotes? I think we'll just do token string. We don't need token quotes. Okay, so how did we do it? We have to do check and skip, right? So we lose skip white spaces, and over here we'll have void skip white spaces, which would, while current is equal to advance, sorry, I think this would handle the edge case. Is alpha wrapper. Okay, how do we do that then? Is alpha, okay. Is alpha current. When we do just pass it to the and now we have to make a token. Let's make a struct. But tokens, we can't make it like inside the class, right? Because we are going to be using the tokens. Yeah, so we'll just keep it out over here. And now we have a struct token. What the token would do is we have a value and this. Okay, so we have token set token set token type and std string value. Cool. And now we have to do this, and now we also have to make a vector of this. So hash include vector. Oh, I'm sorry. Am I recording still? Yeah. hash include vector, and then we make a std vector of token pointers. We'll call it token list. Oh, I'm sorry. Just be in caps. So now what we're going to be doing is token list dot pushback, and then we're going to be calling the tokenize id, tokenize alpha. Should I do it like this? Tokenize alpha, and see, I think I mean, no, we do have brackets and stuff. I was thinking of like inside the while current, inside of this loop, I was thinking instead of having different if else cases or switch cases, what I was thinking of doing is we're going to be just switching on is alpha current, and for case 1 we're going to be using this, and for case 0 we're going to be just pushing an integer. But we do have brackets and stuff, so that won't be possible. But it's okay. Tokenize alpha. Then we're going to be having a void or a token pointer tokenize alpha, which doesn't take anything actually, and we just make a new token pointer, new token, wait, do we call it this or do we call it this? And while is alpha current string temporary buffer, I think we'll make it a string pointer. How did I implement this over here? Okay, first we'll make it like normal string. Let's see. While is alpha temporary buffer. Okay. Temporary buffer dot pushback current, and we just advance so we have this now, and so now okay, we'll just make it new token value, token type is equal to, let's make it token string for now, and new token value would be equal to temporary buffer, and we just return the new token. I think after the tokenize, what we'll do is we'll just do temporary display function. So we'll just do display all tokens, and what we'll do is an int counter int for token pointer current token in token list, we'll just do an C out of the current tokens value and type, right? We also need the type, so I think I'll have to write a supplementary function over here. I think first we'll see out the counter. One second, see out the counter, and then we'll do this, and then the value, and then after some space, or like we'll do it on the next line. We'll add some space over here, and then we'll just do current tokens token type. Then we'll have a new line. Why is that an error? Cool. Okay. Display all tokens first of all. Okay, this is supposed to be like this, and get a warning. Multi-char constant. Oh, I'm so sorry. This is. Am I actually like retarded? Are we good now? Yeah, we're good now. Let's do Aryan Kumar. Great. Crashes. How does that work now? Oh, is it because I was using like, what if I use like Aryan Kumar? Okay, it breaks then. Okay, so we have to employ this over here also, right? That's why. This should work now. Cool. It's working. We don't need this. Now what we want to do is we want to increment the counter, right? So what we'll do is plus counter every time. It's the first thing, and yeah, and then we want to have a token type also, right? So we'll have a private function, or we won't have a private function. We could just like do it std string. We'll call it token type to string, and we'll take a token type, token set, token required token, and we switch on the required token. And in the case of, okay, I'll just copy this, I guess. So in the in the case of token insert, we return token insert. Why is that an error? Oh, we did return this within quotes. I'm sorry. Yeah, cool. So token into string value int left right parenthesis, and then we have a default over here. Okay, what we'll do is return unidentified token token insert, and then what's into string value, wait, into string to one string value. Why do I keep copying that? Now string, right? To value. Yeah, value. We have int. We have left parenthesis. We have right parenthesis. I think it should be good enough. Just add a bit of indentation to make it look prettier. 1, 2, 3. Should I do it like that? Oh, no, this is good enough, right? Okay, what we'll do is, we'll do it unidentified unidentified token, and then we just write out the required token. Okay, no, we have to append this. This is good enough. So now token type to string. Not a big fan of this small t, so token type to string, and now we're going to be calling this while we print this. So we'll do token type to string, and what we'll do is Arjun Kumar. Great. So now we are passing for token like string tokens, and this took me about an hour to just get here. Like, this is so, I'm not like happy with my speed. I I'm actually, like, not kidding, I'm actually very pissed off with the fact that I spent the first 10 minutes of a video doing like .h file and .cpp file, which is very stupid. Like I could have started with like the working before, but whatever. So it's like, it is like, it makes things like dividing stuff into implementation file and like a header file. It makes stuff easier, but I shouldn't have given that much time. And first of all, I shouldn't even have been so much confused about that in the first place. So it was kind of bothering, and it still is a bit weird that I thought of that for so much long time. Whatever. So now we're gonna be writing a function to tokenize for alpha characters. Wait, sorry, not alpha characters. Else if is num. How do we see if it's an integer? Is al num. How do we work with tokenize int? Can we minimize this? Okay, tokenize string, tokenize colon is digit. Okay, if is digit tokenize integer. Should I call it tokenize integer or tokenize digit? I'll just call it tokenize int. Cool. So we have tokenize alpha over here, and then we have a token pointer, tokenize int or integer. Should I call it integer? Yeah. What we'll do is we'll make a token pointer to new token, and we'll just call it will be a new token, and std string temporary buffer, and while is digit temporary buffer dot pushback, push the current, and then we advance. Okay, first of all, this has to be like this. Then we have the new token types. The new token type is equal to token int. Should I call it token integer? I mean, I'm calling this 1, 2, 3, 4. Call it integer. Token integer. Now we have this. Cool. So we have token integer and new value should be equal to temporary buffer. And now we obviously have to return the new token. Let's run it again, and let's like insert into my db aryan 141. Let's see. Great. Of course, we have a lot of more stuff to do, but at least we have a start. And now we apply a switch over here. I really wanted to use. Okay, I'll use this because we also have a token comma, right? Because something like Aryan, Aryan Kumar, like 1, something like this basically. So we have token parenthesis and we have token comma. So, so we gotta add token comma first. So. And then where do we have it again? In the tokenize function, first of all, okay, we don't need to do it. What we'll do is we'll switch the never type properly, switch the current, and in the case of token okay, no, in the case of this, what we'll do is we'll do a token list dot pushback, and what we'll push back is tokenize okay, I'll just I remember I already know it, that in the compiler implementation, when I wrote the compiler, I made a different function for it, called it like, not a different, sorry, I made a single function for the entire switch case, and I called it tokenize special. And what we'll pass is like just different like cards to it. So like if I show you tokens dot pushback tokenize special, and this looks very clean, but I'll just do it the stupid way now, because I'll just like new token is equal to, I'll have to write this for like every 3 case, and I obviously I know there is a very much better way to do it using the functional approach, but I'll do it in the next. I just don't feel like writing that. I don't know why. So we'll just call it token left. Sorry, token left parenthesis. Would this work? Cool. Now token. No, I don't like this. I don't like this. I'll just push do token is not pushback, tokenize special, and we'll just tokenize token left parenthesis, and then we'll break. Cool. Now we gotta implement the token. Okay, first of all, let's just copy all of the cases, like case 1, 2, 3. By the way, guys, if you don't mention this break over here, like if you're writing it manually, of course you're going to be writing it manually, and if you don't mention the break over there, trust me, this would give you some of the worst bugs which you have seen. Like, personally, while developing the compiler, like this was a massive headache to like work around and find these bugs. So, and by the way, we're going to be having a default, and what we'll do is std cout, and we'll put out an error, unidentified token, unidentified character, unidentified or unexpected. Character. Just call it a Lexer or an unidentified character. And then we'll just spit out the current, and should I exit? Wait. Tokenize special. Okay, first let me write the implementation of tokenize special. So we have a token pointer tokenize special, which would take it wouldn't take anything, I'm sorry. It would take a token type of new token type. And what we'll do over here is we'll create a new token called new token, and new tokens token type would be equal to new token type, which we have passed. Why is that an error? Token type is unidentified. Is that so? I don't think so. Token set, I'm so sorry. Token set, new token type, and this should be in small, and new token value would be equal to current, and we have to advance, and now we're going to be returning the new token. Cool. As simple as that. So why is this giving? Okay, that is why left parenthesis and comma. So we have, this is the left parenthesis, this is the right parenthesis, and this is token comma, if I'm not wrong. So token comma. I think our Lexer is done. The first part of the first video is done. Now you have to write a parser, but I'll just okay, what we'll do is insert into my, okay, by the way, okay, it's not even done. We haven't classified for like int token and like token insert, and for this is alpha, while is alpha current, or current is equal to because basically if someone wants to write mydb like underscore mydb, right, so we have to also implement this over here. If is alpha current or current is equal to, sorry, underscore, so tokenize alpha, and then we are doing this. And what we do is basically we have to search the vector. We have to create a vector of keywords and we'll search in that. So create a vector of keywords and search the new token value over there. If found, okay, no, we won't create a vector, we create a hash map or an ordered list. So unordered map list makes it easier also. So I'll just do it, like everything, then we're gonna be running this. So what we'll do is we'll do hash include unordered map, and in alpha, okay, first of all we need to create this, right, like std unordered map of, it's going to be mapping string to token if I'm not wrong. Insert okay, it's going to be string to token list, token set, I'm sorry. Keyword map, and that would be equal to, okay, 1 second. Now for example, insert would be equal to token insert 1 2 3 4 insert, and then we'll have into, and we should also have a token delete, right? By the way, this string is gonna, like, I'll just push the token keywords, the keyword tokens on the top, so it becomes a bit easier. Token value, insert into, insert into value, should I call it values? Insert into mydb value. Technically the thing would be a single entity because we're going to be wrapping the entire thing in brackets. So yeah, I don't want to think about the syntax too much. I mean, I have a lot to think about when it comes to binary trees, sorry, B trees, and how I'm going to be implementing that. So the thing is, I'm thinking of wrapping this entire project within tomorrow and day after tomorrow, because I don't want to lag behind in my college examinations. I don't. My CGPA has already fallen off a cliff. It used to be 7.8 in the first semester, and now in the second semester it's 7.3. I honestly don't blame myself too much for it, because first of all, I don't understand why, like in second semester of engineering, why are we supposed to, more specifically in second semester of computer science engineering, why are we supposed to uh, dive so deep into mathematics, like learning about Fourier series and stuff? Number one, why are we supposed to go and learn so much about physics? Also, why have to we go and learn so much about electrical science? It doesn't make any sense to me, and some could argue that electrical science has some significant value. Maybe, I don't know, but I think what happens is, instead of teaching us what we are supposed to know as computer science graduates, they just focus on the normal conventional system. which is teaching you a bit of mathematics, and this makes you a jack of all trades and master of none. Like our core curriculum of computer science is so messed up. Like they are teaching us stuff like that would have been taught in the early 2000s. It's so outdated. So it doesn't matter. No one cares about like what is being taught to us. No one cares. So I'll stop complaining and I'll focus here. So we have a token value. So we'll do token value, and then we have a token delete. So actually we wanted sorry, notepad, and so we have the insert into db name values this, and then what we're going to have is delete from. So you're going to have delete and from, and then we're going to be having and then we have search in, delete from and search in. Okay, so delete from, search in. Cool. Delete from okay. So now we have this now. Okay, first of all, for all the 4 of those, we have to like token value and 1, 2, 3, 4 token delete delete from token search in 1, 3, and then do we need to space it a bit more? No, wait. Am I still recording? Yeah, great. Cool. So we have this now, and now we have to create 4 new definitions over here too. Insert delete would be token delete, and we have to make it case insensitive. So we have to make it case insensitive. Delete from search in. So delete from search in. Cool. This should be good enough if I'm not wrong. And we'll just copy and paste it, and now we can just change this. I think there should be a better way to do it, but I cannot think of one right now, so I'll just do it like this. Search, and then we have in. Great. So our keyword map is ready, and I think I'll just write this down, like the syntax of the DB. Temporary working syntax documentation. Temporary working syntax documentation. So first of all, insert into DB name values or value element 1 comma dot 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 comma element in. We also need to write create, like create new database and db name. And also if you have multiple tables, so create new table name and use database. Great, that's great. So we gotta have create new table database and use. Okay, create new database table and use token use. Create new table or database and use. So 1 2 3 4 5, there are 5 more things. Then we just below n we're going to be piping all of this, so I have to write a case for this. In case token create okay, I think I'll just 1 2 3 4 and we have token new, so we paste token database, token table, token use. Get rid of this code. Okay, now we have this, and now we have to add 1 2 3 4 5, if I'm not wrong, 5 more entries over here. 1 2 3 4 5. Create new database table and use. It's going to be token create, token new, token database, token table and token use. And now we copy this, paste this, and create new database table use. Great. One two three, 1 2 3, 1 2 3, 1 2 3. Okay, this is a terrible way of doing it, but it's okay. One two three, 1 2 3, 1 2 3, 1 2 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1 2, and put this back. I think it's good now, right? So create insert. I think it's called CRUD, right? Update. We also need to write update, right? Okay, update. So first we have create, insertion, reading. How do we read now? Search in, okay, insert into table, right? Search in table value whatever, and delete from table value. Okay, so delete would be delete from table value and update table okay, update and where. So those are going to be our final. Update table update table, how do we do it? Update table value, update table where okay, we also have to now account for like equals operator. So we're gonna have an equals operator, less than operator, and a greater than operator. So update table where, how do I this is a bit confusing. So update table, and I think we'll just update table where condition create new table name and the name of the like okay, we also have to work over here, update table where condition, and for the condition we're going to have equals, less, and greater than. I think that would be good enough. Update t1 where id1 is equal to id2 with update where with cool, update where with, and we also have a token equals token less than greater than. Token update where with equals less than greater than. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. We have token update. We have token where. We have token with. We have token equals. We have token less than. We have token greater than, and that's it, I guess. And now we also have to write for token update with where would go over here. One, two, three. Update. Token update. Where and with. Cool. 1, 2, 3, 4, and update where. Cool. 1, 2, 3, 1, 2, 1. 1, 2, 3, 1, 2, 1. Cool. Now over here we also need to account for okay, the first would be token token less than and then we would have a token greater than, and for the case of equals, because we can't scan double equals to, first we advance if current is not equal to equals again. So basically what I mean to say is, see, first when we're going to be reading a double equals to, we're not going to be reading a double equals to, we're going to be first reading the first equal to of the double equal to. So when we read that, we get into the case and then we advance. So our current would be pointing to whatever is next of the first equal to, and whatever is next of the first equal to is in the second equal to. That means we don't have the double equal to operator, so hence we'll just throw the error over here. Should I just wrap it in another, like a function, like void throw Lexer error? Okay, I'll just do it over here. Cout Lexer unidentified character at index. Just pass in the index also, if I'm not wrong. We did have the index, right? Where it was on the cursor. Unidentified character at index. And now we just pipe this, and now we pass in the character. Now we just exit, if I'm not wrong. By the way, we also need to have a token exit, so okay. Now, am I still recording? I always have to keep checking whether I'm recording or not, because I'm not sure, but whatever. So okay, by default what we'll do is we'll just throw Lexer error. Wait, it's just giving me an error because of this. Cool. Case 0, we advance if the current isn't equal to, wait, if the current isn't, after advancing, if the current isn't equal to the double equal, isn't equal to the second equal to, then we'll throw Lexer error. Okay, but okay, I'll just token equals now we actually need in the tokenize alpha. Okay, first of all, let's tokenize also the token. Okay, 1 second. Should I just, okay, I won't do it. So we have a token exit. Now we don't have to write that. Token exit to be token exit, and now exit would be token exit, and copy it, and great. So now we have this. What else do we need? Okay, now we need to do keyword map find. Okay, wait, no. If keyword map dot find new token value is equal to keyword map dot end if it's not equal to keyword map dot end. So basically we just overwrite the token type of the new token to be equal to whatever keyword this is. So new token value. Cool. Now how do we create new table? And over here also, okay, how do we create a new table? Like, let's do create new table t1, and we'll have an integer id, we have a string data, something like this, and boolean is should I put colon over here? We'll have a string which would be data, or if we have a string which would be data. Okay, I'll just I'll do it later. I'll just make it like very important. Work on this. Now let's just okay, now let's just run this and see what's happening. What we'll do is we'll do create new database db1. Why is that so? Okay, should we wrap this inside an else? Create new database db1. Create new database db1. Oh no. Okay, see, this is another thing which I forgot to notice. What we'll do is, because see, db is a string. Anyways, so what I was saying is, like, for an example, consider something like db and consider something like a db named db1. So both of them are valid, because once we start passing the alpha, what I think what we could do is we could just basically just simply push the first character, because we only have the restriction on the first character. And anyways, we have checked whether the first character is valid or not before calling the tokenize alpha function. So actually over here, if you would notice that if is alpha current or the current is equal to underscore, we just call the tokenize alpha function. So basically what the current is currently pointing at is already a valid whatever, like it is valid, it is allowed to go in the stream. So what we'll do is we'll just write in the temporary buffer, and we'll push back the current. Then we'll advance while is alpha current is al num. We'll just do it as al num. So basically it's either underscore or either alphabetical or numerical. So basically either underscore or either alphanumeric. This should work. Create new data base db1. Cool. See, now it works. Now let's do okay, we'll not actually, you know, we won't exit. Why would we exit? When we are throwing the Lexer, we won't exit. We'll just simply print this. So now we manually have to break wherever we are calling this. So cool. So this would make things a bit more complicated, but doesn't matter. Just break. And in the default also, we also need to throw Lexer error and then break. If we break, we're going to be getting out of this. Cool. So now let's run this and see what's happening. Let's do create new database db1. Okay, create, and now let's put this simply new. Okay, sure. Throw Lexer error, then we break. So why are we, when we are breaking off the default? Oh no, okay, we're not supposed to continue passing it, right? Okay, what we'll do is we'll create another enum. So we'll just do, actually we'll make it over here and we'll call it type def enum. It would be basically Lexer status, Lexer fail, Lexer pass. Does that sound weird? By the way, why is this double indented? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 tokens as far. Cool. So now this, we have this. I think the tokenized function should return a Lexer status, right? So the tokenized function, I can't believe it's been 2 hours and I'm still working on the Lexer, but okay. Okay, now what we can do is actually we'll just return Lexer status. We'll return Lexer fail. We'll call it Lexer error. Lexer fail sounds stupid. So Lexer success, Lexer fail, success and fail. Okay, yeah, that's good enough. So we'll return a Lexer fail, and we'll return a Lexer status over here also. What's wrong? Okay, while current, and then we'll just return Lexer success. Okay, and I think, actually it makes our life easier, because the thing is we don't need to break now. Why we don't need to break is because in the default section, basically we are supposed to, the tokenized function would return a Lexer status, and if there is some kind of a failure, so we throw the Lexer error, and we don't need to break because the Lexer error would itself return a Lexer status. It would return a Lexer failure after displaying the required message, uh, and then whatever it is returned, we'll wait. We have to do this. Sorry, this would be good enough if I'm not wrong. Because in the default is basically we return from the function, and what we return is basically what we get from the throw Lexer error, and what we get from the throw Lexer error is also the Lexer status, and the Lexer status is explicitly mentioned to be Lexer fail. So I think we'll just return throw Lexer error. Again, return throw Lexer error. And we return Lexer success, and over here tokenize. Okay, we get the thing Lexer status, Lexer status. I'm very bad with naming variables. Lexer status, Lexer. What do I call it then? Lexer main. Lexer status buffer. I don't know. I'm such a genius when it comes to naming stuff. Lexer status buffer, and what we could do is, now this would look cool actually. Handle. Okay, inside the private we'll also have an int command count, and we'll do command count is equal to 0, and after this we'll increment the command count plus plus. You know what, actually I'll do a time function over here. Record the time here using our time function, and if we look current status, like if the current status is equal to Lexer fail, std cout command id command count failed, and the time required, the time in which the command was executed or whatever. So we'll just do like 0.2 ms, I guess, for now. Else if, see, there is one thing about readability of code which I think makes sense. Like, I don't know if it makes sense to you or not, but what I want to say is basically, see, if the current status would either be Lexer pass, like Lexer success or Lexer fail. So if the current status is Lexer fail, uh, we print this. Else we can just simply do else past, like we can just print out past. But the thing is, that isn't readable as much. So what you have to do is basically you have to understand the fact. See, it's easy for me right now to, while I'm coding this, it's easy while I'm programming this. It's easy for me to understand that if the current state is not Lexo fail, it's going to be obviously Lexo pass. But let's say after, if someone else is reading this code, or even if I'm reading this code after like a couple of months or so, what's going to happen is I won't understand it right away. So it's going to be a bit easier if I explicitly mention it. So current status is equal to Lexer success. Just do std cout command id command count failed in executed in 0. I don't know 57 milliseconds. Actually, I'll get this up. If and else if. Cool. Now let's see how terrible our code is. So insert into, let's create new database. Also, we could track the history of commands, maybe using a boolean switch. Anyways, create new database db1. Okay, we have to add a new line over here. Do we add 2 new lines? What? Okay. Create new database db2. Okay. And actually I'll just do this. Let's just not display the tokens as of now. Okay, what we'll do is put a dollar over here. Again, put a dollar over here. Command ID. And then we'll add 2 new lines. So okay, we'll just write it over here. And we'll again write it over here. Cool. Create new database db1. This would fail, I know. And I want to add colors, like if it passes and if it fails. So yeah, I'll do that. So also add colors to the prompt. So I know, very honestly, maybe I'll have to scale down the functionalities, like even though it's a basic CRUD database, But even all of these functionalities, I'm pretty sure I'll have to scale down some of them because it's gonna be too complicated. Not too complicated. I mean, it's gonna be too time consuming or too complicated. Maybe even too complicated. I don't know, but we'll see. So for now, first of all, I think our Lexer is done. I'll deal with this later. Deal with this later. But as far as this is concerned, I think people like in my adjacent room are having a fight. That's nothing new. Anyways, so one second, I'll just. Okay, so first, what do we do first? Okay, first I want to just see whether the Lexer is working correctly or not. So I'll just enable the display token. One second. Yeah. I need to create new database db1. Create new database in string. Great. Delete from table one value. I don't know. Rn 141, I guess. By the way, how do we deal with. Okay, we don't have a token string, right? We aren't passing for token string. Wait. Yeah. Create new. Why is that so now? Why did this happen? Okay, we have to flush the token stream right before every write, so it's stupid of me, but it's great you get some entertainment also while they're shouting. So I think for every tokenized call, what we'll do is we'll set the. How do I implement this actually? Okay, we are first calling the initialize every time, right? So in the initialize, I think I'll implement this in the initialize as well because this seems like initialization. I mean, so yeah. What do we have? Like, if I just minimize all of them, one second. Display all tokens. Okay, we have a token counter. Advance current local input buffer. Okay, we have to flush the token list every time we initialize it. Not a big deal. Token list dot. How do we like? What do we call flush or empty? Oh, it just checks whether it's empty or not. Like remove. How do we delete all the elements of vector? I'll have to see one second. How to flush a vector in C++. Okay, wait. Clear. There you go. Token list dot clear. Great. So now we have this. Okay. And throw Lexer arrow. Oh, it's working good. I think this should work. So insert into database db1. Why did that happen now? Oh, okay. Wow, this is so stupid. Why is this happening now? Because we are skipping the white space, right? Okay, what we'll do over here is if current is equal to end of line, I guess. Wait, we skip the white space. Is alpha current or current is equal to underscore? Okay, now I want to deal with this error. Basically, if we add any kind of trailing white space to it, this would fail. Uh, okay, do you notice this? Like, see, it failed on index number 27, but if I increase this, it's always failing on the last index. Why is that so? Because we are getting in this switch case after the else call, right? Skip white spaces is working correctly, right? Current is equal to empty space, and current is not equal to. Okay, you know what? We'll just deal with. Okay, I'll just make a kind of a to-do list. So, to-do list db engine, and number one, deal with how to create the specifications of the new table, something like create new table t1, and it would be, we have an id which is of integer type, we have a name which is of string type, or we could also do varchar, and we have is student which is of boolean type. Cool, we have this. Number two, what do we deal with? Deal with a bug of trailing white spaces. DB engine to-do list. Great. Now we have this. Okay, we'll deal with this later. Okay. I don't know why this was giving me an error, but whatever. So we'll first create new database db1. Great. And then use database db1. This should, now see, since we have only implemented the Lexer and we aren't parsing this entire thing, anything which is like correct with respect to the allowed characters, anything would be executed. Like even something like this which makes no sense would be executed. So this is complete nonsense. Even this would be executed because we're not parsing it basically. So parsing is the integral part which makes sure that whatever command we're executing is syntactically correct. So this is complete nonsense. Okay, now this should give me an error, and I don't know, hello. Great. And delete from search in update where with, and then we have this, and we have this, and we have this, and we have this, and then we have hello. Let's see. Wait, there you go. Delete from search in update where with left right less than greater than equals, and yeah. Okay, you know what, actually just one little like twitch in the code. What we'll do is we'll minimize this. I love this feature in VS Code, just minimizing stuff. I think it's available in like all code editors, but whatever. So What was that in again? It was in tokenize. By the way, we're not tokenizing strings. I forgot right now. Tokenize strings and stuff. It's been 2 hours and I'm still writing the Lexer, but okay, I think we have made progress. And I think it's going to be like, it would take me like more half an hour because I'm going to be implementing colors and stuff and time and stuff, so whatever. 1 second. So uh, wait. Okay, but we are tokenizing for token string, right? Okay, token string and token ID are supposed to be different. This is supposed to be token ID. And yeah, we had to make this thing in the tokenized special, like if new. Okay, what we'll do is new token value, we'll use ternary operator. So new token new token type is equal to token equals. If that's true, then the value would be equal to double equals, else we'll just write current into it. This should work. Why isn't this working? I don't know. Wait. String. Wait. String test is equal to. Should I do it like this? What if I write test over here? Value is string, right? And both of them are string. Wait, let's just. This is weird. Like, we can set the new token value to be equal to current, but if we do it over here, okay, why is okay, this was on there. Yeah. So now it's not giving me an error, and we can use current over here, but if we use current in the ternary, it's giving me an error, I guess. Okay, then I'll just do it like this. If new token type is equal to token equals, if that is the case, then new token value would be equal to else new token value is equal to current, and then we advance. It's great. Now this is the first thing. Now we had to deal with strings and IDs and stuff. So okay, we don't need to deal with token quotes specifically. If we encounter a token quotes, okay, first of all, initialize and tokenize, display all tokens, tokenize integer, tokenize alpha. Okay. Token ID, right? Yeah. Now we write another function which would be token pointer tokenize string, if I'm not wrong, while current, and the string can have anything, right? While current is not equal to and current is not equals to we'll have an std string or temporary buffer yeah, what we'll do is we'll just do temporary buffer dot pushback, and what we're going to be pushing back will be the current value, and we're going to be advancing. And what we'll do then is first let's create a token pointer. New token would be equal to new token, and new token token type would be equal to token string, and new tokens value would be equal to temporary buffer. And then we simply return the new token. Great. So now when do we call the tokenize? You know what? It makes more sense to call it tokenize ID. Token ID is unidentified, is that so? Okay, wait. Tokenize ID. Wait. Tokenize ID. And over here, for the case of we are supposed to account for advance, and then we just do a token list dot pushback tokenize string and token ID. We need to define token ID first, so let's just define token ID, and we need to make another change over there. I'll get into that later. Token ID, and over here also token ID. Token ID, yeah, I think it's good enough. Now over here, actually, what we didn't notice was tokenized ID is good. In the tokenized string function, we have escaped the first quotes, but what we'll do is while current is not equal to I have an elegant way of writing this, which is elegant by my standards. I mean, I'm a terrible programmer, so bear with me. While current is not equal to the closing quote, you know what, we'll advance in over here itself, and this would be advancing the opening quotes, the closing quotes. Actually, I'll just make it over here. This makes more sense. Now, we don't care about this. Yeah. So, by the way, I'm sorry. Now, inside this, while the current is not, like while we haven't encountered the ending quote, if we encounter the last basically if we reach the end of the string, so if current is equal to null byte, we throw some kind of error over here. Okay, now how do we see? This is okay, but let's put the mic over here. So if the current is equal to null byte, if we encounter the null byte, we have to, how do we return? Uh, Kind of conflicted, because if we encounter an error over here, how do we propagate this knowledge over here? Like when we encountered an error over here, then we simply threw a Lexer error. Is there some implementational mistake which I have made? Okay. By the way, was I passing for exit? Don't exit, great. But how do we deal? It's a simple and last thing, but basically, kind of confused over here. Okay, I have a very hackish way of doing this. We'll have a boolean string parsing error, and I think you guys would know what I'm trying to do with this. I'm going to be using class boolean value to basically do it. It's a very bad way to do it, I guess, but anyways, string parsing error is equal to false. If string parsing error throw parsing error, now we'll have a similar function to throw Lexer error, which would be throw string parsing error codes not matched in the given command. Closing codes not found in the string present in the command. Then we return a Lexer fail. That's great, but even this, like even if there is some error, we are pushing something which is not very not good. It just feels not good. But anyways, what we'll do is we'll just set the string parsing to be equal to, and we'll break and we'll set the string parsing error to be equal to true, and then we break, and after the break we're gonna advance. So what would happen, what would happen if we're already over here? Okay, we still stay on the null byte. Okay, it works, I guess. So let's see. This should work. ID string, great. And this should not work. Why are we displaying the thing? Okay, okay, yeah. So it is working. So we just don't call the display function over here. It's great. Okay, so now I think it is working now. Just we need to. I just want to add some colors. So 1 second. I know we have to like use byte stream or stuff, and it's called what do you call it? And ANSI color codes. 1 second. I'm actually searching on my mobile phone. ANSI escape codes. Sorry. And I think we need to import OS. I think I'll just tell you one thing just for the sake of trivia. In Python, when we're using these byte streams to print something or print the color, you have to run os.system clear first. And I think that's the same for here. I don't remember exactly, but I assume so. Just include OS. We don't need to include OS, right? You can just run a system command like this. So we'll just do CLS, assuming that this is running on a Windows system. Cool. Now I'm just looking up for the color code for wait and ANSI color code C++. Okay, we have to define, right? Okay, so we'll use definitions over here, and we'll define red. We'll define fail actually, like fail color, and yeah, I mean maybe it makes more sense. So it is /e this O semicolon 31 M success would be green 32M. So I'll just check the syntax, and we don't obviously have this, and we do define default would be white, and for white we have 37M. So we'll just put 37 over here. Okay, now how do we use this again? Okay, we just prefix this, right? So let's do cout. We'll just do, wait, it was supposed to be, wait, success. Let's see whether it works or not. It does, great. But now, you know what, I'll just call it default. It's called default. Okay. By the way, this is light green, right? Okay, I'll do light green later. But Aryan Kumar. Okay. Now over here also we pipe default and we'll fail over here. Wait. Insert into table data. Okay, I'll actually also do it in the Lexer error. We'll just pipe fail over here. We'll pipe another fail over here. Why is this? This should not work. Hello. Okay, we have something. Great. Okay, it's. I don't know why pressing Control C is not like. You know what? I'll pipe a default here every time. And hello there. And this should not work. And this is a string. Sorry, this is not a string. Okay, what's happening over here? Aren't we returning something? Oh, we're not. Hey, Bhagwan. So sad. Right. This is a string. This is not a string. And hello. Sorry. Hello. Great. So we have this. Wait, why am I exiting this? Never mind. Are we still recording? Yes, we are. Okay. So now we just need to do the time thing, and then we'll be good. Should I put the time in the main, like over here? Okay, wait. Could also add the time over here. And Okay, we just do how to record time in C++. Okay, so there's something called as hash include chrono, so I'll just do it over here. Chrono, this is for the time thing. And what we'll do here is, like in the evaluation wrapper, first thing what we'll do is we'll use an auto start timer is equal to std chrono dot high resolution clock. Now and auto stop timer would also be that. And then we'll just do auto well, duration or time would be equal to duration chrono duration cast to microseconds, std chrono microseconds. We'll do milliseconds actually. Milliseconds. Stop timer minus start timer. And then you'll just see it out over here. See out over here in time ms. This makes sense, I guess. How do we print this? Oh, not count. Okay, time not count. So this is very complex. I didn't know this. But complex. It has its own, like you have to do this and then you have to do this. So it's basically has its own that stuff, but whatever. So let's just see. And by the way, tokenized string and stuff is done, and write or toggles command to record the history of all the commands executed, like a DOS key or something. Now, yeah, I think this should be fine. I mean, I closed my command prompt, so I'll open it again. cd db, name it db engine. Where am I exactly? cd src. And what we'll do is we'll do g++ main .cpp as main, and then we'll execute it, and also we'll clear the screen. This is a test, 11 milliseconds. This is a long test. Makes no sense. It makes no sense. How is this executed in 0 milliseconds and the last one in 11 milliseconds? But whatever. Should we do microseconds? With that, this is a test. Wait, what we'll do is in test is equal to this, while test minus minus test is again equal to this. Let's see. This should add a bit latency. Wait. What the hell? Okay, we'll cool. Okay, like it's good enough for now. And now what we'll do is we're not gonna add the time over here. We're not gonna make this its own class. It's stupid. And now in the evaluation wrapper we have the handle function. So the evaluation wrapper is we have the start timer here, we have the stop timer here. Everything would be done between them. You're counting the time, we're incrementing the command count and whatever. So now what we have to do is we have to get a parsing. We have to create a parser now. So all of this, I think we successfully created a Lexer. So the first part of this video is officially done in 2.5 hours, and that was the easier part, I think. But whatever. So let's create the parser. So we'll have a class parser. My mouse is very dry. 1 second. Drink some water. Now we'll have the public and private thing over here also. In the public we'll have the parser constructor. Cool. Okay, we are supposed to do this now. Okay, now similar to like Lexer status, we'll have a parser status. Call it parser success, parser failed. Cool. Okay, and even in the private we have a parser pointer. We have a parser main parser, then main parser would be equal to new parser, and in the handle okay, first we have to put this right. We parse it we tokenize it, and then we do a parser status is equal to parser status current Lexer status. I think it would be better, Lexer status, and current Lexer status, and current Lexer status. Current parser status would be equal to main parser, and we're going to be calling some function over here, and over here we'll just calling using the Lexer to tokenize the string, the input buffer actually, using the parser to parse the token. How do we pass the token stream now? Okay, now this would be complicated, I guess. Success and fail, okay, but so we'll have to wrap this, right? So if the current Lexer status is equal to Lexer success, get token stream main parser. Okay, there would be a parse function. We'll write a parse function, and then okay, we need to do a lot of stuff over here. Wait, this is supposed to be here, right? We're not supposed to do this, so like, yeah, because okay, wait. You know what? If current Lexer status is equal to Lexer fail, or current parser status is equal to parser fail, we copy this, we paste this. Else we don't use else. If like this would be pass or success. Wait, success command id fail executed. Good. Current parser status. Wait, so we have to declare it first, right? Main parser pass. Okay, first of all, we need to write the get token stream on the Lexer. So we should have a get token stream function. So it will return a pointer to std vector of token pointer. I think we don't want to, make a copy of the entire token stream. So get token stream. We'll just return the address of token list. Easy enough. It should work. Now we should have a parse function. Wait, I'll just minimize this. Minimize the entire thing actually. Now main Lexer dot, okay, not dot, first of all. Now we should have a parse function, and which would return a parser status parse, which would take in the address. So basically std vector token pointers address, we'll call it token list address. Now we have the address, right? So if I do something like this, would sound very stupid and silly, but let's call t is equal to dereference of token list address. Would this make a new copy? I think so. So then what's the use of... I don't think so we should do it like that. I mean, we can just... What we'll do is, let's just std cout, this is from the parser thing, and now let's just return parser success for testing purpose. Am I still recording? Yeah. For testing purposes, so Aryan Kumar, cool. Hello. Okay, now we are getting the MS thing. That's great. So we can just chop this up over here. I don't know, whatever. So what I want to do now is, let's just do for token pointer current token in the dereference of current token, token list address, token address. This is the current token list, current token value, and we'll do current token value, and then we'll do std. Why is this? Did it crash again? What happened? Cd db engine CLS and CLS, and oh wait, we have to go to cdsrc and CLS and g plus main.cpp. output this as main, and then we run this too, and this would not work because, yeah, it should work now. Aryan Kumar value, okay. Can we make this by reference? I would be very happy if you would be able to do that, but I think now if this works, yeah. So now I don't think we are making a copy of it. Great. So now what we do basically is we just switch. Now we need to have a very concrete reference of what we are doing, like what the syntax is basically. This would not be hard actually. The thing is, now I am in the flow. And trust me, the beginning was so terrible of this video. Like, I just spent so much time like working around header files and stuff. But I think once we're in the flow, things just become a bit more easier. So first we have the create. So in the parser we should have the advanced function. So wait a second, write the function. So we switch the current tokens with the current tokens of token type case, what do you call it, token create, I guess that's the first thing, token create. So we have create, use, insert, search, delete, update, token create and token use. Insert, search, delete, update, exit. 5 more. Search, delete, update, exit. Insert, search, delete, update, and exit. Okay, and then we're gonna have a default case in which we're gonna be throw syntax error. Okay, we're gonna be returning that. Are we doing the same? We were doing the same over there, yeah. So throw syntax error, and in the private of this, so what we'll do is it would return the parser status and throw syntax error cout std wait syntax error unidentified token, do token to token type to string, and then do current. Do we pass in the current token? Or we just pass in the current token? It's just error token we return parser fail. Cool. We need to create the abstract syntax tree, right? Cool. Throw syntax error, return parser success. Cool. Okay, no, but we have to keep, this won't work, right? Because we have to keep a track of what the current token is pointing at. So you know what, we'll actually not do this, but do something like return parse create. We pass in the current token, something like this. And we add a bit space. Yeah, parse create. Yeah. Parse create, parse use. Okay, I'll refer back to my code. So if I go to parser, okay, this is reload this. Let's go to parser, and now the node type, right? Okay, we have a node type, and then we have this, and then we have an AST node. Okay. Cool. First, we need to create the interface for working with all of this. So we have to create the node set. So type def enum, we'll call it node set. The node set can be create database node, node create table, yes, node use, should be comma, right? Node insert, node search, node delete, node update, and node exit. Do we need to, am I doing something wrong over here? It looks right. Create database, create table, use, insert, search, delete, update, exit. Cool. Now we need to create another std string node type to string. We could take our node set required node, and we just, yeah, switch on the required, node, and what we do then is, in the case of, okay, we only have all of these cases, right? So, and we are also handling unidentified, yeah, we are. Cool. be returning create 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Create table. Use insert search node delete node update, and we have node exit. One, two, three, four. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I don't know. Now at the end of it, we just return, like what we had returned over here was unidentified token plus required token. We just return unidentified node, and we just do required node. Cool. Now we need to create the struct of a node. So struct of the node. Now wait, yeah. Called AST node, abstract syntax tree node, even though it doesn't actually abstract syntax tree because we won't have a tree. I don't think so we'll have a tree, but whatever. Enum, what's it called? Node set. Oh, we don't need enum. Node set. No. Node type. Then okay, if we see we'll have a string ID payload. So we have a string string payload. I think it's called ID payload. Then we also need to handle condition somehow. Now we would also have an std vector of token pointers. Would we have token pointers? Okay, that doesn't make a lot of sense. Wait, if we have something like that, so okay, we also need to have another node, which should be node update, and we should have a node sub values, right? And also maybe node condition. I have to think about this node sub values, and we just create another one for node sub values. Okay, and it won't be a wait, could have a node set Okay, I'm getting a bit confused over here. Uh, it should be a vector of AST nodes, right? There you go. That's why. So now it's like now I'm back on track. It makes a bit more sense. So vector of AST nodes called children. And how do we handle the condition? Okay, that would be later. Update would be later. Don't care. What else do we have over here? Supplement. Okay. We'll just create that ad hoc. And am I still recording? Yeah, cool. So error token. Why is that? Is it type to string? You just dereference it, I guess. Then oh, I'm so sorry. It should be wait unidentified token. Oh wait. Oh, token type. Syntax error unidentified token. It's not unidentified, it's unexpected token. And then there you go. So okay, we don't care about this. AST node to string struct token. This is where we start the Lexer. This is the parser code, and this is the main code. So now the AST node thing is okay. Now we need to write the parser thing. So now in the parser I had the advanced method. What was it called again? Parser node to string. Okay, wait. Where did that function go? Struct parser. Wait. Proceed. Let's return the no. Yeah. You know what? What we'll do is in the Lexer, we'll add another token first of all. That would be token end of command. So once not over here. The token struct not struct token. It was enum token. I'm sorry. First in the enum token set, we'll add another token end of input. Token end of input. Then we need to first mention it in here as well. Okay, and we'll append an end of input token every time with the Lexer. So before we pass it, token pointer end token is equal to new token and end token. Wait, why can't I type properly? Token type would be equal to token end of input and token list dot pushback and token. That's it. Now okay, I think the Lexer thing is done. In the parser, we have a private this and public this, and I think in the private section of this, what we'll do is we'll have an std okay, std wait, you know what, I'll make a copy of it, doesn't matter. But why do we need to make a copy of it? You can just wait, what we'll do is we'll just pass it like this, and okay, now this is going to be terrible. Oh, I haven't written anything. Okay, get token stream. Okay, wait, what we'll do is it would pass in the address of the token stream, and what we'll do is we'll have a local copy of it. So local copy of token stream would be equal to the reference of token list address private std vector of token stream wait, local copy of token stream, and we need to flush the local copy first. Local copy dot erase, I guess. Was it erase? Why can't we erase it now? It's a vector only. This makes no sense. We were doing the same over here. Wait. Clear. We were using clear. Okay. Didn't know that. But doesn't matter. Use clear, right? Cool. We make a local copy of it. Now, what we do is we can actually, you know, do current token. Okay. We could actually should we do it? Or we'll do it. We'll do it. It would also add a sense of symmetricity, if that's a word, but you get the point. Main parser initialize, and we pass in main Lexers or get token stream. Then over here we just do parse. Cool. Initialize, need to make the initialize function, and it would be a void initialize, and we would take in this. Now we copy this, and we have to also need to write int token number, and is equal to 0 token number. Great. Now we don't need to do it because it's already initialized. Even though, see, the drawback of this method is we have to call the initialize in the pass function, like similar to how we have to call the initialize in the Lexer function. We now have to call the initialize in the pass function. So apart from that, it's cool. Now we don't need to do it. You could just switch the current tokens type. Yeah. 2, 3, and why is this an error? I don't know. Let's get rid of this. Looks good. Now we need to write the parse functions. So parse state, we need to write the parse status create, use 1, 2, 3, 4, 5, 6, 7. So create a parse, something like this, am I right? Parse create, why is parse status, wait, parse fail with this, Why is that so? Wait. Turn parse create parser. Oh, it's parser status. And I did. So parser status parse create. I'll just write the declaration of the function. Would that be okay? I didn't write the parse create, no? Parser create. I'm sorry. Come on. Okay, parse create. Okay, we have this. So now we have to do parse create, use insert, search, delete, update, exit. Use insert, search, delete, update, exit. Use insert, search, delete, update, exit. Search, delete, update, exit. Cool. Now we have this. Now we have to populate all of these. 1 second. 1, 2, 3, 4, 5, 6, 7 functions. And we can just parse use. So we're going to be returning and we don't need the current token. We can just do a throw syntax error, and over here we can just do current token. Cool. Now parse use parse wait. Yeah, parse 23 insert. Token parse search. Exit. So I think this is good enough. Now we need to start writing. Okay, first we'll write the continue function. So okay, we need to have another boolean continuation. Is that spelling mistake? Continuation error. Also continuation error is equal to false. Now in the advanced function what we'll do is proceed with token end. Okay. It would proceed and it would return the new token. Cool. So it would also set the current to be equal to a token pointer proceed. Okay, let's call it syntax error. error is equal to false, and proceed. What we'll do is, if we'll proceed with node set okay. Proceed is basically if you have to proceed with node end, it would check whether the current is node end or not, and if it isn't node end, it would give us a syntax error, and if it is node end, it would just proceed. Cool. So node set required node if current token. Why do we have current token? Current, wait, it should be token set, right? I'm sorry, token set required token if current token type is not equal to required token. Yeah, we raise an error. Is equal to true. Return current token. But then this would. Okay, this is not the correct way to handle it. Syntax error is true, we return the current token. Makes kind of sense, but okay. But else what we'll do is what are we supposed to do? Token number plus plus current token is equal to local copy of the token number, and we return the current token. So we have this ready. Now we start populating the functions. Once we populate all of these 7 functions, and we do some tests, and we see it's working correctly, and we also need to better the syntax error thing, then get done with the video. So parse create. First we do proceed with call it check and proceed. Check. What did I call it over there? Proceed. I'll call it proceed here again also. I don't know. We'll proceed with token create. So the syntax is I have to write a syntax over here so it would be easier. Create new database. DB name. Wait. Can't type properly. Or create new table. DB name. So we proceed with create. We proceed with token new. Now we need to create a new AST node, right? Okay. AST node pointer evaluated node. Let's evaluate it node. Let's call it that. And I think there is some kind of memory issue which I'll encounter over here because I'm not freeing up stuff, right? Okay, I can just make this over here. This is very important since we have a REPL environment, write code to since we have a REPL environment, write code to free up all the token and node space acquired by using new after running every statement could wrap this in some kind of function like free tokens and free nodes in their respective classes. Cool. We'll do it later, but for now we have a new AST node and if okay, you know what, we'll in the proceed we'll just exit for now because we have a syntax error, and we'll also do the fail thing, and we do default over here also. Wait, one second. Default, yeah, cool. So okay, now we just write a check function which would, I think, check okay, what we'll do is we'll have a token type check and would take token set required check token if current token type is not equal to required check token, wait, where did I, no, not supposed to, we could do this, but I was thinking of just simply you know what, we'll just do a throw syntax error here and we will exit for now, and we have to change the behavior of this code. throw a syntax error again, else we'll just return the current token. If check token, wait, let's make it void. This is very confusing, so make it void, void, and we'll just do a check of token ID, and if current value, current tokens value is equal to database evaluated node type would be equal to node create database, else if current token value is table evaluated nodes, node type would be equal to node create table, else we use syntax error, because technically someone could write create new nonsense and nonsense name. So yeah, else we throw syntax error. Cool. Now we need to proceed with token ID. Now okay, we check token string. Okay, at the end of it we proceed with the token string, and then we proceed with the token end of input. Check token string. Now evaluated node, wait, we call it payload. Why are we calling it ID payload? Okay, we just evaluated node, where do we write this now? One second. How long has the stream been? About 4 hours. Okay. Yeah, ID payload, we'll just call it payload, I guess. It's good enough. Proceed with token string. Evaluated nodes payload would be equal to, okay, over here what I was doing is I was using a string pointer. If I open this, using a string pointer like such, I'll use it again. I mean, what's the issue? And payload would be equal to current token values address. So I think we have successfully passed for the parse create function. Uh, Create new. Okay, first of all, I'll just this looks a bit nicer. Proceed. Create new check ID. Cool. So the parse create function is done. Then we just do a return parser success. Cool. At the end of it. Now, similarly, we need to do parse use. Parse use would be easier. So we just do copy this line. At the end of it, we'll again return success. And the syntax would be, I think I should write this in double quotes like this. My legs are hurting. I've been sitting down for so long. Let's drink some water. So we'll call it syntax for parse create. One second. Syntax for create. Actually, let's do it like this. How do you do bullet? Okay. Let's do create new database name, create new table, great, this looks better. Now syntax for use, you're gonna be using a DB name, right? Right? We don't use a table, right? Yeah. So we'll proceed with token use, check for token, token string, and evaluated nodes, node type would be equal to node use, and evaluated nodes payload would have the address of current, if the check passes, so current token's name, right? Value, yeah, the address of the current token's value. Then we proceed with token string, and then we proceed with token end of input. That's great. We have this also done. Now we're going to be doing parse insert. Insert is going to be a bit tricky. So is all the remaining four. Exit is going to be easy. So I'll do exit first. Don't need to proceed. We need to check. Last token end of input. We just need to check. So parse exit evaluated node is new AST node. Proceed token use. Wait, token exit. Do we have a token exit? Token exit. Great. So now we have insert, delete, insert, search, delete, update. So basically the CRUD functionalities, the core CRUD functionalities, we need to parse for them. So token insert. Okay, we need to first define the syntax. We didn't define the syntax over here also. So 1 second. It's pretty self-explanatory. So syntax for exit would be surprisingly exit. Now syntax for insert would be insert into table name value wait should I use value or values value, and then we have a bunch of stuff over here. Then after proceeding with token insert, what we'll do is we'll check for we'll proceed with token into insert into, and then we'll check for a token string. Then what we'll do is evaluated nodes payload would have the address of current tokens value. Now we have this, we proceed token string, proceed with token value, okay. This is going to be a bit tricky, because we proceed with token left bracket parenthesis while current tokens type token type is not equal to token, right parenthesis, if current, why is this given? Okay, if current token type is equal to token, like if we encounter the end of input before encountering the token, right parenthesis, token end of input, check for empty inserts, maybe in the generator, I guess. But if current token type is equal to token end of input, what we'll do is we'll just do by the way, we are returning the parser success, right? Cool. We'll just do throw syntax error. So evaluated node dot children dot pushback parse children. So we need to write this function. Okay, we need to check. Okay, we'll do it manually. If insert into values. Now value can have, it could be like 1 comma aryan, so it could be an integer and string. So if current token type is not equal to token integer and current token type is neither equal to token string, we'll again throw a syntax error. This looks like a very hackish way to do it, but whatever. Syntax error, and then parse child if current tokens. Now while proceeding also we need to make sure we are proceeding with the right stuff. Integer, proceed with token integer, else proceed with token string, and then proceed with token what if we encounter, okay, what we'll do is wait, we'll make it an infinite loop. So while true, and if after proceeding with that, if the current tokens type is equal to the closing parenthesis, we'll break out of this loop else we'll proceed with a token comma. And this has to be integer, else we'll proceed with the token comma. And then after breaking, oh, by the way, I need to also proceed with the token right parenthesis, and then we will break. And then after breaking with the right parenthesis, we also check for the token end of input, and we return parser success. I'll just look into this once again. One second. So insert into check for string, proceed with value, proceed with left parenthesis while true. If we get the end of input, throw some text error. Actually, or if we try to insert, okay, we'll just do it with null, doesn't matter. Or maybe we could insert null. Parts children, if the current token's token type is equal to token integer, proceed with the token integer, else proceed with token string, and if the current token type is okay, no, but we'll handle this over here anyways. Like, if it's not equal to integer or string, we'll throw a syntax error. We'll pass the child. If it's token integer, you proceed. If it's not token integer, we proceed with token string. And if we have token right parenthesis, we proceed with this. Proceed with that and break. Else we proceed with token comma, and we repeat everything again. This looks foolproof. Now I just need to write the parse children function. We'll do ast node pointer parse children, and I think I'll take this up from here to here. Parse children. What we'll do then is actually we have made sure, right, that it's integer or string. Cool. So what we'll do is we'll make ast node pointer new child node is equal to new node, and new child nodes type would be equal to, how many types do we have? Okay, wait. What we'll do is we'll add two more node types, string node and int node. Node string and node. By the way, I think the update thing would be a bit tricky, so we'll do it in the next video. So work on the update, especially the condition thing, and node integer node string, node integer, we also need to write this over here. So for the case of node string, what we'll do is we'll node string, and for the case of node integer, we'll return node integer. Hope I've spelled that correctly. Yes, I have. And now we go back over here. So it's I'm sorry, it's new AST node, and node type would be can you use a ternary over here? Current token type is equal to token integer. If yes, then node integer, and if no, then node string. This would make it harder to see, I guess. Node string, and new child nodes payload would be equal to, I think currently we are yeah, I think we just do current token, and we do its value. I think that's enough, right? Because we have a new child node whose type is decided. It's either node integer, node string, and the payload is also here. So we just return this, I guess. So we'll return the return the new child node. So now we are passing for children. I think the insert is done. Should I compile and see what's happening? I mean, I haven't compiled like in years. I don't know. I know it's gonna give me some kind of syntax error, but undefined reference to parser, parse update, search, delete, update. Okay, we do have to. Okay, let's do return parser success, and we do return parser success. Wait, parser success, and again over here we do the same. Oh, great. Insert into db name value 1 rn 231039194. Let's see. Great. This is how did that happen? This is the current. Okay, wait. Are we even reaching here? This is from here. Or did I like not follow my own syntax. Wait, could be possible. Insert into table name value. Let's display the tokens first. I hope there is no issue in that, but wait. So what we'll go over here, and in token stream initialize, in the tokenize function, at the end of it we'll just display the token, and we'll do insert into db name value 1 Aryan Kumar 231039194. Let's see. Insert into, wow, okay, this is a stupid error. Insert into, so it's a tokenization error, I guess. It's the error in the hash map. 1 second. Jeez, this is so disgusting. Such stupid errors. And this should be over here also then. Yeah. I'll just make sure. Insert into value. Why is insert here twice? Insert into value delete from search in, create new database table, use update where with exit, and now with gaps. 1 second. Insert into value delete from search in, create new database table, even though I copied it, so it's going to be the same, but still use update where with and exit. So by the way, I'll just look at this. So this would be token into now db name token id value left parenthesis integer comma string comma integer right parenthesis. This is great. So now we'll disable the display all tokens. We don't want to display all the tokens again. Now we'll just simply where did that go? Yeah, we'll just move this also, and now we'll do insert into db name value 1 Aryan Kumar 231039194. Why is that so? Token ID. Okay. I think I know what's happening. I think I already know what's happening. It's because in the Lexer, if I remember, while we were checking. Okay, wait. I have to first. Insert into table name, tname actually, not table name value 1 Aryan Kumar 231039194. Why is that so now? The tokenization is okay. So there is an error while parsing, and that would be a stupid error. I mean, pretty sure, but it should be over here. Oh, see, this is the reason. This is ID. This isn't a string. Insert into ID. Because table name would be an ID. It won't be a string, even though it is a string. But the way it's different is because we won't use codes to resemble it. So now I think it should work. I think even see, I'm such an idiot. Token ID, and then over here also we'll have a token ID, and exit doesn't have anything like that, so cool. And this should work, pretty sure this should work. So insert into tname value 1 Aryan Kumar 231239194, please work, kill me. Token ID, where do we have a token ID now? Oh, that's why. This should work, and I know I'm saying this like I've said this like a million times, but I think this should actually work. Insert into tname value 1 Aryan Kumar 231039194. There you go. Great. So this is being parsed correctly. Now, if let's say insert, if you remember previously, what we could do is we could type in random nonsense. Like if we type in insert nonsense, give us an error, and it would exit, yeah. And insert into table name value, if you just do 1 Aryan and 231039194, you forget the bracket. There you go. Cool. So our parse insert is working. Search and update. I'll do search and update in the next video, so I'll just write that down. Actually, delete also involves conditional things, right? So I just want to like do all the conditional stuff later. So should I wrap this video up? I think I'll wrap this video up right now, guys, because the conditional stuff would be another kind of a headache. Because see, the syntax would be something like over here, update table where, then we have a condition. Or should I just do it right now? I mean, I'll do it right now, doesn't matter. So let's start with update. So the syntax of, it's not going to be that much of a headache. So syntax for update would be update tname where condition, and for parsing condition, okay, we also should have a node type condition, right? Okay, we'll just do a node condition over here first. Yeah, that's why I had commented that out. I was thinking of it. Why is this an error? Condition. Oh, that's why. Never mind. Okay, now we have node case node condition, and then we'll do a node condition. Now we just need to pass for the condition, right? So I'll just for the passing condition we need to call another function, so that would like parse the condition. So it's similar to parse children. So we'll have ast node pointer parse condition. Now parse create, parse use, parse insert. Okay, now update where condition. So condition could be something like, okay, we'll handle the condition over there. But still, for the sake of syntax, should we write it over here? Condition would be like id1 is equal to node int slash string. So id1, so we have an id over here. It should be the name of the column, I guess, and then relational operator, and then int string, int or string. So cool. So what we'll do is we'll just do evaluated node is equal to new ast node, and evaluated nodes node type would be equal to, how long I have been streaming? It's 4 hours 17 minutes. I hope my OBS does not crashes. It would be sad, but whatever. So node update and evaluated nodes, what do you call it, payload would be equal to, wait, proceed with token update, and then we check for token string. After checking for token string, what we'll do is the evaluated nodes payload would have the address of the current tokens value, because the current token has been checked to be a token string, and then we see, again I am making this mistake, it has to be token ID. Then we proceed with the token ID, then we proceed with token where, then we need to evaluated nodes children would be equal to parse condition. Parse condition, and I'll just take the syntax over here, and the parse condition, wait, this is the syntax of the condition of parsing condition. First we have open, like you obviously have brackets, and actually I'll just write this before I forget. I have experienced this from the compiler project, that if you don't, while we are parsing, if I just forget to return the AST node which we constructed, I don't think C++ would give an accurate error, and debugging that would be like, I was on the verge of tears while debugging that. That was very painful, but whatever. So I'll just make sure that, one second. So I'll just make sure that for every parse function we are returning the parser status, and also checking for the parser EOF or EOI actually, but whatever. I'll just call it end of input, end of input. So now Actually, we have to do this wherever we are returned, but I get the point here. Should have an ID over here, ID, then a relational operator, then an int slash string. So something like enrollment number is equal to 56, or enrollment or marks is less than 60, or employee name is equal to RN, something like this. So what we'll do is we'll first proceed with the token left parenthesis, and then at the end of it we'll proceed with the token right parenthesis. And what we'll do then is ast node pointer new, calling it new node, and let's call it condition node is equal to new ast node, and condition nodes node type would be equal to node condition. It sounds funny. I think what we'll do is we will put the ID in the payload. Okay, we will create another. This is where we have to keep on rectifying the node structure. String sub payload so we'll put the ID in the payload, and we will put the int slash string in the sub payload. By the way, what I can do is, instead of having a node condition, we can specify what kind of node condition it is. Can we do that? But I'm thinking of the generator, what would happen over there, because there, okay, we can just switch on the child, like it would be the parse node condition less than, okay, that's great. So what we'll do is, instead of having a node condition, we'll have a node condition equals less than greater than. Greater than, greater than, less than, and we need to implement better this also, node condition less than, greater than 1 2 3 4 5 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5. This looks a bit too much spaced out, right? Am I an idiot? I am an idiot. Hey, Bhagwan. I'm sorry for anyone who's actually watching this. You have to watch me press delete for like half an hour. But I think a very important part of, like, at least for me, is does the program look good? It just feels good to look at. Of course, it obviously feels good to look at a properly indented piece of code, but whatever. So, we have this. Cool. Okay. Equals, of course. I forgot equals. Great. We have this. Node condition equals less than greater than. So what we'll do in the parse condition is that we proceed with the left parenthesis now. Uh, now we check whether we have a token ID or not, and if we do, condition nodes payload would be equal to have the address of token, oh wait, address of current token value, proceed with token ID. Now we check token, what do you call it, okay, we switch, I hate the syntax. We switch the current token token type case token less than, greater than, and equals token less than, greater. Do we have greater than, right? And we have token equals, and in the default what we'll do is we'll just throw syntax error if we don't have anything apart from, if we have anything apart from these three. What we'll do in the case of token less than is the condition nodes node type would be equal to node condition less than, and we break. Greater than. I'll just decrease this 1 2 3. Wait, we break. Greater than token equals. I think it's good, right? We need to proceed also, right? I think I'll just do it over here. I was thinking of creating a new function for itself, like one that will proceed no matter what. So we won't do it like this. 1 second. 2, 3, 4. And now, wait. So let's put something over here. Condition node type would be less than, and then we also proceed with the token less than. Wait, token. Oh, I'm so sorry. This is supposed to be the node type. Hit node condition less than, token less than. Cool. The names are a bit different. That's a bit weird, but it's okay. And that's the case of less than. In the case of greater than, node condition greater than, we proceed with token greater than, and in the case of token equals, we'll proceed with condition equals. Less than, or node condition less than, proceed token less than, break. If we have a token greater than, or node condition greater than, or proceed with token greater than, token equals, node condition would be node condition equals, proceed with token equals, and we break. And in the case of default, we throw a syntax error. So we have this, and now you just check. You know what? I could have written a check and proceed function, which would check and proceed, because whenever we are checking and proceeding, we are doing like both of them, right? Like we are checking for token ID over here and proceeding with the token ID after we have this. What we'll do is, okay, I have an idea. Wait, we'll do a token check but how do we get the reference to the previous token? Okay, okay, I have an idea. Wait. This would clean up the code. uh, we'll do token. We'll do a token check. Wait, check and proceed. What we'll do is we'll do a token pointer buffer pointer should be pointing to the current token. Now, okay, we're gonna check also, right? We're gonna check. We just return the buffer pointer, but at the same time we just proceed with the required token, and that would then, we haven't done anything with the current token as of now, but what do we do now? Like, is this correct? Like, if we first take a reference to the current token, then we pass the required token over here. Then if they are different, we throw a syntax error, else we increment it, and then we return the buffer pointer. So I think this is good. This is good enough. Now what we do is now we need to deal with this, and this would go in the sub payload. So condition node sub payload would be equal to check and proceed with check and proceed with what do we want? Okay, but this could either be, this isn't the best test case of this function. So this is the best, like when we are sure it's going to be id or it's going to be a relational operator, but over here we're not sure whether it's going to be an integer or a string. It could be an integer or a string, but over here we are sure. So what we'll do is I'll just rewrite this piece of code, and I'll show you, like, it feels more elegant. We'll just do wait, condition nodes payload would be equal to check and proceed, and we check and proceed with the token id. But this would give me an error because check and proceed is returning actually a pointer to the previous token while checking and proceeding with the current current token type supplied. So from the token pointer we have to extract whatever we require. So actually if I put this over here, you would see we have a value and token type. The payload deals with the address of the value. So I'll just put this. Should this work? Yeah, this should work. Now all of this is wrapped in this. It looks so beautiful, right? So I'll just remove this. Just make sure. Yeah. So now we have this. And now, see over here it can either be parse child. I think we'll just use the parse child function. So we'll just do parse. But parse child handles. Let's write another function, ast node pointer parse string and integer. New ast, new node type should be children, token type is equal to token integer. Oh, okay, we can't use it. We are calling this function parse children like repeatedly. The parse children function isn't executing itself repeatedly, like by itself. Like we don't have a loop or anything kind of here. So we can use it over here. Sub payload would be parse children. So why is this giving me an error? String pointer, cool. Is it string pointer? So what we'll do is we'll just check. This feels brute forcing, but whatever. Current token type is equal to token integer. So what we'll do is we can use our check and proceed function over here. Great. So current node sub payload would be equal to the address of check and proceed. We check and proceed with token integer, and this would give us value. Else, it did make our code a bit more nicer, I guess. Current token type is equal to token string. It's similar with we just write the sub payload to be equal to whatever address we receive from the check and proceed function, and we want to check and proceed by passing in token string and the value basically. So else we just throw a syntax error. Cool. Now we have this, and we were past proceeding with left parenthesis, so now we have to proceed with the right parenthesis. Oh, we are okay. And then we proceed with token end of input, and then we can just return parser success. Why is this an error? Oh shit, I'm so sorry. We are in the condition thing, right? So we're not going to be token right parenthesis, and we're not going to be proceeding with token end of input over here. We'll just return the condition node, and after that okay, so where do I basically link the condition over here? So update, okay, payload. I think I'll just do a pushback, and to get the condition from the node update access condition node from the node access current node children 0. Great. So now this would deal with the right bracket. Now we just need to proceed with the token end of input, and I think the parse update is done. That's great. Now we only have 2 more, I guess. Yeah, and it's not gonna be tough because see, we basically had to formulate the entire condition, parse condition thing and how this works. And the parse condition was a bit tricky, like it had its own complications. But now I think we are set, and now I don't think this will take much time. So let's first decide the syntax of delete. I mean, we did decide something, right? Over here. Delete from table value. Cool, okay. So syntax for delete would be as follows: delete from table name value, and so now you would see this becomes so easy, right? Because what we'll do is first of all we'll just do a ast node pointer am I an idiot? We are just writing to the evaluated nodes. Evaluated nodes node type, sorry, to its node type would be equal to node delete. Now it becomes so easy. We just do check and proceed, token delete, and we have from an evaluated node okay, the syntax is a bit weird. Delete from table, it should be where, right? and we have where. Okay, so where, and then we have a condition. So now uh, the t name would be in the payload. Evaluated nodes of payload would have checked and proceed with token ID. Token ID's values address. See, it becomes so elegant now. Now we just check and proceed with where token where, and now what we'll do is evaluated node, and the condition will again be in the children's 0th index. So what we'll do is children pushback parse condition, and then we just proceed. We don't check and proceed with token, what do you call it, end of input. We don't check and proceed with token end of input. We just proceed with token end of input. The difference in both of them is actually very simple. But what happens is, if we check and what check and proceed is actually doing is, we just point on some kind of token, and check and proceed would just check whether that token is of the supplied token type or not. And check and proceed would then, after checking, it would proceed to the next token. But the token end of input is the last token. So when we apply check and proceed with on token end of input, it would check the token end of input whether it's matching with the current node, current token type or not, and whatever. And if it matches, it would try to proceed, and that should give me an error. So we just check. Yeah. We just check. I'm sorry. I thought why would we proceed? I was just confused. Wait. So I'll just write this over here. So it's very important. So I'll actually do a roundup once we're done. So yeah, we are checking. So yeah, sorry. So we don't actually proceed. We just check for the token end of input, and again we check for it. Yeah. So update is done. So I think we are good with delete. See, it becomes so easy. It's like, I don't know, about approximately 10 lines. So just coming back on track 1 second. Yeah. So parse delete from, this would be in the payload, token ID, where condition, token end of input. Cool. I'll just check the token condition. Proceed less than and sub payload. Cool. We have this. So see, it becomes so easy. Now I think update is done. This is done. Now we just only need to write the code for search. And how long it has it been? It's been approximately 5 hours. Okay. So what we'll do now is write syntax for search. Do we call it search or do we call it find? I don't know. Search and find. Find sounds better. Find is easier to type, but search in table name. where condition, as simple as that. I think I've been listening to the same song since 3 hours, so I'll change it 1 second. So search, and yeah, so I think it's easy, like it's very similar to what we had written. Evaluated node type would be equal to node search, 1 second, node search, yeah, and then proceed. We just do proceed. By the way, we don't even need to call check and proceed. We can just call the proceed over here. My code is currently kind of a mess between calling proceed and calling check and proceed, but I'll just call proceed here because we don't need to call check and proceed. We need to call check and proceed if we still need to have some sort of an access to the previous tokens pointer. Like over here, we need to use check and proceed. Similarly, we can just proceed with token search, and then we also need to proceed with token in, and then again over here, evaluated nodes payload would be equal to, I think we had to just copy this just for the sake of like documentation, I guess. So evaluated nodes payload would be equal to check and proceed, check and proceed, which can proceed with token ID, and we pass in its value, the address of its value, while checking and proceeding it. So see, it becomes very elegant now. Now we just proceed with token where now evaluated nodes children dot push back, or actually I'll just write one more thing down, do tests on all the main parser functions. Okay, so evaluated nodes children pushback. What we'll push back is parse condition. Cool. See, it becomes so easy now. So I think we are done with our parser now. I'll just look through the code, like look at the code. Remove. Let's do it like this, I mean. I can just, how to decrease the indentation. Tab, okay, no, sorry. Evaluation wrapper, int main. So we have the following types. Okay, I don't need this anymore. Somehow handle condition. We are handling condition by pushing it into the children vector token type Lexer is cool, right? So I'll just we need to change the behavior of this, and I'll actually just look through. Yeah, parse condition, parse create is okay, and parse use is okay. Insert, search, delete, update, exit, and okay, looks cool. Now we're going to be running through this, deal with how to create the specification of the new table. I'll deal with this in the next video. Okay, I'll just make a bifurcation list, what I'll do in the next video and what I'll do right now. So we can just draw a line over here. Good enough. This would be in the next video. I'll deal with this right now. This would be in the next video. Better way to handle honestly, I think I'll just do this in the next video also. Maybe this is kind of in a dilemma. Oh, this would be in the next. This is a bit complicated, I guess, so I'll just put this in the next video. This is just plain stupid, but work on the update, especially I've done this. So I've done this. I'll deal with this. I'm sorry, I'll deal with this right now. Deal with this right now. Deal with this right now. Cool. So we just only have to deal with 4 things. First is whether this program compiles or not. Let's see. It does compile. Great. So first, I'll just do one thing. I want to get rid of the trailing white space error. So insert into db, insert into ename1 value 1, let's say, right? But if I just do this, why is that happening? This is a Lexer issue. Obviously it's Lexer issue. I mean, it's written over here, Lexer error. So we need to fix this. Okay. This is from, where exactly is this from? Like, should I track the source of it? Wait. Wait, it's not like this. std cout, this is from here. Don't need a new line, just do this. Insert into tname value 1. This works, this won't work. Okay, so we are here, right? You know what? We'll just do I'm sorry. Before the default block, if the case is of empty, like trailing white space, we just advance, I guess. Would that be okay? If we're already on the trailing white space and then we advance and while current is not equal to I think it means the same. I mean, empty byte is considered to be what's the opposite of truth? Falsy values, I guess. So this won't give us an error if I guess shouldn't give me an error. Insert into the name value 1 rn, and why is that so? You still get an error. Oh, I'm so sorry. I'm so sorry. I know what's happening. It's actually this is happening. I'll tell you. I don't know why. This error was also in the compiler thing, I guess. What we could do is but there shouldn't be okay, I'll just break if that's the case. And when we break, we get out of this loop. I guess this should work. Insert into tname value 1. Great. So we have dealt with this bug. Let's make another thing called done. Done. Okay, this. For every parse function, we are returning parser status and also checking for the parser end of input. Okay, so now we have to. So our Lexer is, I guess, spotless. Now we need to work on rectifying if basically seeing if there is any kind of error in the parser. 1 second. I don't know why I maximized all of these. I'll just make this like this. Yeah. So now we go to the parser. Syntax error is equal to true. Okay, I have to work on the syntax error thing, right? It's very important. Why am I inserting? Parse children. Okay, we are like just making sure that we're returning stuff. Parser fail and return current token, return buffer pointer, return new child pointer, return condition node, I guess. And over here, check for token end of input and return parser success. Check for token end of input, return parser success. Check for token end of input, return parser success. Check for we aren't checking for this over here, right? Check for token end of input and then we return parser success. Check for token end of input, we return parser success. Check for token end of input, return parser success. Check for token end of input, return parser success. Great. So now we have this working. So we can also, how long has that been? Okay. I quickly have to wrap this up. I have college tomorrow at 10, I guess. Yeah, at 10, so I have to wake up. And I'll stick with the parser. Yeah, cool. So it's done. We just implement the proceed thing. So I can proceed with token ID and its values address. Now we don't need anything else. We can remove this, remove this, remove this, remove. Hey Bhagwan, where was I again? Okay, anyways, we'll go from bottom to up. So proceed or update, check ID. If you're checking with the ID, oh, we were here itself, right? You would check. If I just do control Z, yeah. We don't need to check and proceed. We can do this. Token ID is value. We have this working. Delete from token ID where parse condition token end of create. Search in token ID where okay, it's great. Insert into by the way node search, node delete. I'll just this feels more natural to do it like this. Yeah. So now in token insert, wait, sorry. Insert into, okay, over here now what we do is we pass in the address of the address of check and proceed, and in second proceed with token ID and we pass the value, basically the address of the value. So we don't need this anymore. And check insert into token ID value. Okay, now and oh, I think I checked this, right? I'll just go through it again roughly. Cool. Parse children. Yeah, so this is good. Let's put this over here. Evaluated node type is node use. Proceed with token use. Check token ID. Okay, again we have to. I think I can just copy this. Check and proceed. Token IDs value. Yeah. Now we don't need this. Don't need this. Don't need this. Don't need this. Cool. Proceed. Token use. Use token ID end of input. Cool. I'm sorry. Create new. Okay, over here we can't use second proceed because there is some kind of bifurcation. See, I talked about this previously also. We can't use second proceed where there is even a slither of dilemma. We can't use second proceed. So over here, the ID can, like, if it can be table or database, but if it's database, we change the node type accordingly, right? And yeah, we proceed with token ID, then we have a token string. Okay, over here we can use check and proceed. So check and proceed with token string, and we pass in the value of it, and we don't need this. Token string. Oh yeah. Now we have parse condition. I think we were using check and proceed over here, right? So okay, so proceed with token left parenthesis and ast new node, and then check and proceed token value token ID's value. Cool. Then we have this less than, greater than, equal, just throws in text error if none of the three, and integer, and cool. This is working good. Parse children is working good if I'm not wrong. By the way, in parse children we aren't proceeding, right? This would give us an error, I'm pretty sure. Okay, we have to check this. I have to see how is this used. Like, okay, it's only used over here. Oh, okay. We are proceeding over here. We are doing some conditional proceeding. I thought that the we could also have implemented. I think it's a bit more cleaner to implement this inside, right? Just copy it. Parse children, and we get the current token value, and if the current token type is equal to token integer, we proceed with the token integer, else we proceed with token string. We return the new node, and over here we can just get rid of this piece of code. After passing the children, if we have a right parenthesis, we proceed with that, then we break, else we proceed with token comma. And if we encounter token end of input, we throw a syntax error. And yeah, I think we are done with this. Now we are going to be testing. So let's first test with, should I make a list of all the functionalities that we have? We have create, and let's do wait, tick, and let's do cross. So create, we have use, we have insert, we have search, delete, update, exit, cool. So now we first compile this, make it this full screen. Now we are going to be doing testing for create, and the syntax of create is something like this. Okay, by the way, I forgot completely that while creating the new table I have to define the structure, so it's a very stupid mistake, but for now, okay, we are passing for this for now. We're passing this for now. So I'll just mention rewrite the parse function for creating the table or something like this. Create table t1, id is integer, name is a string, and I don't know, is student is a boolean, something like this. But for now we have this, so it's okay. So we'll do create new. By the way, as we create new table t1 token table. Oh, okay. Are we doing it like this? Okay, by the way, if we do create new database, we should get the same error, but token database. Great. Doesn't matter. If current token type, this is actually better. Token database, and if the current token type is equal to token table node create, yeah, create new table t1. Okay, still the same error. Oh, okay, we have to proceed with the token, right? I'm so sorry. So if let me use check and proceed over here. Token type. No, what the hell am I doing? Wait, evaluated nodes node type would be equal to node create database, and then we just proceed with token database, and then else if inside of that paste this, and then instead of proceeding with token database, we proceed with token table. Else throws in Lexer, and we don't do anything over here. Oh, okay, this has to be token ID, right? Because see, ID is something like this is an ID. String is this is a string. So while we are writing or like create new table t1, this is an ID. So which I can proceed with token ID, and now I think create new table t1 should work. Cool. Create new database d1, and let's do like random. Okay, it's gonna fail. Create table t1 should also fail. Cool. I think I'm happy with this. Yeah. So create has passed the test. Now we're gonna be using use. So use t1, use okay, let's do table 1. So this should fail, and this again use data db1, use db1 and then let's do random. There you go. So this is also passed. Insert, let's do insert. Insert was actually I think already working, but insert into t name value 1 2 4 rn, and if I just do this, I have to copy it. I have to keep typing it. Insert. Insert into insert into insert. Let's do insert in t name value 1 2. Okay, I think this is also working. Just one more. Insert into t name value 1 2 4. Let's say, and if we do values, we get an error. So now we gotta search. Do for search. How do we use search again? Use. We have done use. Insert as well. Search in tname where condition. Search in tname where id is equal to 7. This is interesting. Are we doing something what we're not supposed to do? Search in check and proceed where, okay, let's do this is before the condition thing. Search in tname where id is equal to 2. Is it crashing before? Is there something wrong with the check and proceed function? I would be very sad because, but the insert was working, so this is before the check and proceed function. After the check. Function. Search in tname where id is equal to 7. Okay, what's happening now? Search in okay, I'll have to activate the Lexer now, like the display tokenized function. Search in okay, what's the issue here now? Token search, token in. So we are proceeding with both of these tokens. See, token search, token in. This is a bit confusing. The insert thing is working, right? I'll just refer to the code of that. So, oh my god. Okay, I get it. That's a very fatal mistake. and I've done this like everywhere. Okay, in 2 places. Yeah, but whatever. I think we don't need the display or Lexer. I don't know why I keep mistrusting the Lexer again and again, but whatever. I think at this point I'm pretty sure the Lexer is spotless. But the reason I activated the display all tokens function is because I thought that there is some kind of mismatch somewhere in the parser, but I wanted to get a hold of it from the display all tokens function in the Lexer. But whatever. So I'll just okay. So what we were doing is search. So search in tname where id is equal to 9. Cool. Where id where okay, we also need to add and or not operators in the conditional thing. We could just keep pushing all of the operators in the children AST node vector when name is equal to rn, and if I do it like this, okay, we get Lexer errors. Okay. And search in, I think it's like, there you go. Search is working. I think everything's working now. Now we do delete. The syntax of delete. What's up? The syntax of delete. Where id is equal to 9. Where name is equal to rn, and there you go. So this is also working fine. By the way, I'll just do exit, okay, and exit with something. This should work, and exit with hello. Okay, fair enough. By the way, another thing is write a way such that even after a syntax error, in the parser we would proceed with the normal REPL instead of exiting the REPL shell. So whatever, exit is working fine. Now we need to just check for update. So update, you also need to write another like a better way of parsing update. Similar insert. What's the current syntax of update? should be over here. Update. This is so stupid. I don't know why I wrote this, but okay, whatever. Update t name where id is equal to 9. Update. Okay, that's why. T name where. Cool. And if I do something like this. Now we need to just pass in like width. So should I do it right now? I'll do it right now. We'll just do proceed with update tname where condition with values. Token where then we proceed okay now where do we keep adding the like the children and stuff? Okay, first we get the code from insert, that is proceed. It's something like this. Copy this, search, delete, update, and token where, and then we proceed with token left parenthesis. I think we'll just create another. We'll call it update values. Update children. I will push into that and update children. So we'll just go over here and in the struct AST node, we'll just do another update children. And now I think if I go down over here, I think it's done. Parse use, insert, parse search, delete, just add a bit space over here. Delete, parse update where condition with v1, v2, blah 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 blah. Cool. The values, which is v1, v2, vn, would be pushed into the update children, right? Update children vector. Now this was working, right? This shouldn't work now. Obviously, I mean, paste this. Great. Update t name where we can also replace with and where. I mean, it's kind of done. Like this is kind of done. But maybe replace where and with in update syntax. Could we do that? Update t name where id is equal to 9 with 1 to rn. Width. Okay, why is that so? Oh, it has to be with. I'm sorry. Now this should work. I'll just copy it and great. And if I do, like, let's get rid of this. Great. So I think even this is working. So shouldn't have. Just place it over here and do all the tests. All the tests are done. And do I like this or wait? Update tname where id is equal to 9 with 1 2 rn, or do I like update tname with no, it's okay. This feels more natural. So I think our front-end part of our database engine is completed, guys. We have written the Lexer and the Parser, and I think all the functionalities, create, use, insert, search, delete, update, exit, are being tokenized and parsed correctly. I think in the next video we're going to be implementing B trees in C++, and then in the third video we're going to be linking both of them together. So I'll see you there, and bye-bye.